This is Algebra 2, Unit 7, Lesson 1 on shifting functions. Now, we talked about shifting functions back in Algebra 1, but there are some certain rules that we're going to look at. And this is going to be true for all functions. We did a little bit when we did parabolas, so let's take a look at what happens with all the functions. All right, so let's consider the functions y equals the absolute value of x, y equals the absolute value of x minus 3 plus 2, and y equals the absolute value of x plus 1 minus 4. All right, without the use of your calculator, graph y equals the absolute value of x on the axis provided and label its equation. All right, so y equals the absolute value of x. That is, absolute value means the distance from 0. So if y is equal to absolute value of x, x is 0, y is going to be 0. If x is equal to 1, the absolute value of 1 is 1. But remember, if y is equal to the absolute value of negative 1, it will also be 1. So it's going to look like this. All right, 2 will be, absolute value of 2 is 2, so 2, 2. And the absolute value of negative 2 will also be negative 2. So this is a v-shaped function. We did this back in Algebra 1, and it should look something like this. All right, so there is y equals the absolute value of x. Okay, now the y equals absolute value of x here. We want to use our calculator to generate a table of values, graph the other two absolute value functions above, and label each with its equation. So I'm going to put these three equations in my calculator so I'll have the same thing on the screen. So I have y equals the absolute value of x, alpha key, the window key to get the absolute value function, it's number 1, absolute value of x. All right, so that's blue. All right, in red, I'm going to do the absolute value of x minus 3, alpha key, the window key, number 1, x minus 3, and then forward arrow to get out of there, and then plus 2. And then the black one will be the absolute value of x plus 1 minus 4. Absolute value, x plus 1, forward arrow to get out of the absolute value, minus 4. Okay, so the blue one will be the absolute value of x we just graphed. The red one will be this one, and the black one will be this one. So let's graph them. Okay, so let's take a look at the red graph. The blue graph looks like what we've already graphed. Let's look at the red graph. Okay, where is the vertex? Where did this vertex go? Well, it went to the right 3 and up 2. Okay, so when I graph that, back here, let me change to red so it looks like it's on the paper. 1, 2, 3, 1, 2. All right, this one went 1, 2, 3, 1, 2. And this one went 1, 2, 3, 1, 2. And here, 1, 2, 3, 1, 2. And here, 1, 2, 3, 1, 2. So here is the red graph. It looks exactly the same except it is shifted. So here's the red graph is y equals the absolute value of x minus 3 plus 2. Okay, now how did that shift? All right, it went to the right 3 and up 2. So let's look at the numbers here. That went right 3 and up 2. That gives me an idea. All right, let's look at the other graph, the black one. From the blue graph to the black graph, we went to the right 1 and 1, 2, 3, 4, down 4. All right, let's see if that works. Let me put it in black so it looks like what's on the calculator. Right 1, down 4. 1, 2, 3, 4. Right 1, 1, 2, 3, 4. Right 1, 1, 2, 3, 4. This one, right 1, 1, 2, 3, 4. Right 1, 1, 2, 3, 4. Okay, so there is my other graph, and you can see the shift on that, and let's look at the values. Okay, so this one is y equals x plus 1 minus 4. Okay, now let's look at the shift on this one. If we had the red one, y equals x minus 3 plus 2, it shifted right 3 and then up 2. Okay, now look at the value right here. Inside the absolute value bars is the 3. Notice it is the opposite sign. It's like using the circle equation or the parabola equation. in vertex form, this is always going to be the opposite sign. So if it's the x on the inside of the bars, or if it's parabola inside parentheses, it's going to shift the opposite way. So this is going to go to the right 3. The outside here is going to be like the y-intercept. It's going to shift up or down. So this is going to be plus 2, so we're going to go up 2. All right, now the black one was y equals x plus 1 minus 4. So following that rule, if it's x plus 1, which way is it going to shift? It's going to shift to the left 1, and since this is negative 4, and it's going to shift down 4. Okay, so inside the bars is opposite direction, outside the bars is the same. So knowing that, what would the graph of y equals the absolute value of x be shifted in order to produce the graph of y equals x minus 6 minus 8? Okay, so for this right here, the 6, let me do it in purple so I know which one I'm doing here. X minus 6 means I'm going to shift 6 which way? Well, it would be shift 6 to the, since it's minus 6, it's going to go to the right. And then the minus 8 means 8 down. So if I take this graph right here and shift 6 to the right, 1, 2, 3, 4, 5, 6, and 8 down, it's going to be like this. If I go to my graph, just to make sure, all right, I'm going to go down here. Y equals the absolute value of x minus 6 minus 8. X minus 6, and then minus 8. And look at my graph. There it is. And it's going to shift way over here. 6 to the right, 8 down. Okay, so the shifting rules are, if it is inside absolute value bars or parentheses or whatever you happen to have, it's going to go the opposite direction, left or right. Outside is going to go up or down, depending on what the sign is. Although we just use the absolute value function, that exercise illustrates the fundamental manner in which vertical shifts and horizontal shifts occur in functions. So in summary, vertical shifting, if you have the function f of x plus k, it's going to shift up by k units when k is positive. If this is positive, it's going to go up. And down absolute value of k units for k is less than 0. So if k is negative, that means it's going to shift down. Okay, now the horizontal shifting. If you have f of x plus k shifts the function left k units for k greater than 0. So if this is plus k, inside the parentheses, it's going to go to the left. And if it's k is greater than, and right, it's going to shift to the right if k is less than 0. So if you have in your parentheses minus k, it's going to go to the right. Okay? So inside the parentheses, remember, is opposite sign. Outside the parentheses is the same. All right, so the function f of x is shown in the grid below. A second function g is defined by g of x equals f of x minus 3 plus 1. So what is the value of g of 0? Well, let's think about this for a second. G of 0, if I plug it in here, my input of x is going to be 0. Whoops, that should be g. G of 0 means I take the 0 and I plug it in here. It's going to be f of 0 minus 3 plus 1, which is f of negative 3 plus 1. Okay, so to figure this out, I have to know what f of negative 3 is. Well, I need to know what the y value is when x is negative 3 on this function. This is the f function. So if I go to negative 3, 1, 2, 3, what's my y? My y is going to be 1. So f of negative 3 is 1. Plus 1 is going to be 2. So that tells me when I have g of 0, the y value is going to be 2. 0, 2 will be right here. Okay, now let's identify how the graph of f has been transformed to produce the graph of g and sketch it on the grid. Okay, so f of x minus 3, which way is it going to shift left or right? Well, it's x minus 3, so it's going to shift right 3, and then this is going to be up 1. Since it's plus 1, this is going to be up 1. All right, so let's take each of these points. If I take this point right here, right 3, 1, 2, 3, up 1. There it is. If I take this point right here, right 3, 1, 2, 3, up 1. If I take this point right here, right 3, 1, 2, 3, up 1. If I take this point, right 3, 1, 2, 3, up 1. And if I take this point, right 3, 1, 2, 3, up 1. All right, let's connect our points. Right 3, there, and there. So every point has shifted to the right 3 and up 1, and I have my new function. We can use these shifting patterns in a variety of ways because they apply to all types of functions. All right, a function f of x has a domain from -3 to 10 and a range of y is greater than or equal, or less than or equal to 22. What are the domain and range of the function x plus 7 plus 10? Okay, so the domain is the x values. How did the x values change? All right, well, let's see. The x values went from -3 to 10 for your domain. Okay, now it's going to shift. How? Well, if it's x plus 7, means it's going to go to the right 7. So we are going to take each value and we're going to shift it 7 this way. So this is going to be -3 minus 7. Oops. And then the 10 is also going to shift 7. All right, so this is going to be 10 minus 7. So your domain will now be from -10 to 3. So the graph is going to shift this way 7. Or excuse me, left 7, not right 7. Wrote the wrong one. Should be the left 7. So it's going to go in that direction. Okay, now the range is y is less than or equal to 22. Well, what is the function going to do to the y's? Well, if it's plus 10, it's going to go up 10. So if we have y is less than or equal to 22, and it's going to go up 10, it's going to be 22 plus 10, so y is now going to be less than or equal to 32. So your range is affecting the y's, your domain is affecting the x's. Because it's x plus 7, it went to the left, plus 10 means it went up. So recognizing shifts of other simpler functions can help us identify prominent characteristics and compare them. The location of turning points is especially helpful. Okay, so let's refer back to parabolas. We did parabolas before. Given the quadratic function f of x equals x minus 4 squared minus 5, answer the following questions. How has the simple quadratic y equals x squared been shifted to produce the graph of f of x? Well, x minus 4 means it's going to shift 4 which way? Opposite sign, it's going to go 4 to the right. And then minus 5 means down 5. Okay? So where should the turning point be if y equals x squared is 0, 0? What is the turning point of this one? Well, we did this when we did parabolas. The vertex will be at 4, -5. Opposite sign, same sign. All right. So if we sketched f below and give the domain over which it's increasing. All right. So if I graph my parabola, all right, its vertex is going to be at 4, -5, which should be about there. And it's going to be pointing up. It's going to look something like this. All right, here's my vertex is at 4, -5, and it will be increasing starting here going over. So it's going to be increasing from x is greater than or equal to 4. Okay, so which has a lower minimum value, the function of f or the function g of x equals x minus 6 minus 10? Well, let's think about the vertex. So the vertex for this one was at 4, -5. The vertex at this one is going to be where? It's going to be at 6, -10. Which one has a lower minimum value? Well, the minimum value would be the y value. We have -5 and -10, so this is going to be the lower minimum. Okay, so we were looking at left and right shifting and up and down shifting. So in class, next class we'll be looking at exercise 5 and talking about horizontal shifting.